Problem 20, Quantum Mechanics. The question is, a hydrogen atom is subjected to the perturbation V perturbation R equal to epsilon cos 2R by A0, where A0 is the Bohr radius. The change in the ground state energy first order in epsilon. In the question, a perturbation is given to the hydrogen atom. We have to find out the first order correction in the ground state energy of hydrogen atom. For hydrogen atom, the ground state wave function psi 100 is given by 1 by root pi A0 cube e raised to minus R by A0. So the first order correction in integral form, this is given by integral 0 to infinity, integral 0 to pi, integral 0 to 2 pi. Then first let us take psi star, that is 1 by root of pi A0 cube e raised to minus R by A0. Then the perturbation epsilon cos 2R by A0. Then psi, that is 1 by root pi A0 cube e raised to minus R by A0. Then d tau, that is R square dr sine theta d theta d phi. This is the expression for first order correction in ground state energy due to the perturbation epsilon cos 2R by A0. Now we can take the constant term outside, epsilon by pi A0 cube integral 0 to infinity R square cos 2R by A0 e raised to minus 2R by A0 dr, then integral 0 to pi sine theta d theta, then integral 0 to 2 pi d phi. Now we can write it as 4 pi epsilon by pi A0 cube, where 4 pi comes from the term integral 0 to pi sine theta d theta integral 0 to 2 pi d phi. That will give rise to 4 pi. So E01 become 4 pi epsilon divided by pi A0 cube integral 0 to infinity R square e raised to minus 2R by A0 cos 2R by A0 dr. Now to evaluate the integral, use the relation cos theta is equal to e raised to I theta plus e raised to minus I theta by 2. Therefore our integral become 4 pi epsilon by pi A0 cube integral 0 to infinity R square e raised to minus 2R by A0. Now cos 2R by A0 we can write it as e raised to I 2R by A0 plus e raised to minus I 2R by A0 all divided by 2 into dr. Now let us simplify the expression inside the integral sign. This is equal to 2 epsilon by A0 cube. Now let us write the integral as integral 0 to infinity R square integral 0 to infinity R square e raised to minus 2R by A0. The first term become 1 minus I dr. The second integral is integral 0 to infinity R square e raised to minus 2R by A0 into 1 plus I. Now we have to evaluate the integral separately and then substitute in the expression to get the first order correction in ground state energy. First let us evaluate the first integral, integral 0 to infinity R square e raised to minus 2 by A0 1 minus I into R. This is in the standard form, integral 0 to infinity x raised to m e raised to minus alpha x raised to n dx. So here the value of m is equal to 2, n is equal to 1 and alpha is equal to 2 by a0 into 1 minus I. Therefore, from the standard integral we have the result 1 by 1 gamma 3 divided by 2 by a0 1 minus I 2 by a0 1 minus I raised to 3. Now gamma 3 is 2 factorial. So this is equal to 2 a0 cube divided by 8 into 1 minus I whole cube. What is 1 minus I whole cube? If we evaluate 1 minus I whole cube, that is equal to minus 2 minus 1 minus I whole cube, that is equal to minus 2 minus 2i. If we evaluate 1 minus I whole cube, you will get the answer as minus 2 minus 2i. Now substitute the value of 1 minus I cube in the equation. You will get the value of the integral as a0 cube divided by 4 into 1 by minus 2 minus 2i. This is the expression for the first integral. In the same way, let us evaluate the second integral. Integral 0 to infinity r square e raised to minus 2r by a0 1 plus I dr. Here again the value of m is equal to 2, n is equal to 1 and alpha is equal to 2 by a0 1 plus I. Therefore, the integral become gamma 3 divided by 2 by a0 1 plus I whole cube, that is equal to 2 a0 cube by 8 into 1 plus I whole cube. What is the value of 1 plus I whole cube? If you evaluate 1 plus I whole cube, this is nothing but minus 2 plus 2i. Minus 2 plus 2i. The value of 1 plus I whole cube is minus 2 plus 2i. Now substitute the value of 1 plus I cube in the expression. You will get the value of integral as a0 cube by 4 1 by minus 2 plus 2i. So we have evaluated the value of the integrals, and let us substitute the value of the integrals in the above equation. Now we will get the first order correction in ground state energy E01 as 2 epsilon by a0 cube within bracket the value of the first integral a0 cube by 4 1 by minus 2 minus 2i plus a0 cube by 4 1 by minus 2 plus 2i. Okay. Close the bracket. a0 cube by 4 1 by minus 2 plus 2i. Now let us simplify the expression. This is equal to epsilon by 2, then minus 2 plus 2i minus 2 minus 2i divided by the denominator. You can write it as minus of 2 plus 2i into minus of 2 minus 2i. Now after simplification, you will get the answer as epsilon by 2 into minus 4 by 4 plus 4, that is equal to minus epsilon by